In this video, we're going to talk about what a scatter plot is and how we can use linear models, so the graph of a straight line, to make predictions and estimates within our scatter plot. So before we are able to do that, we have a couple of vocab words that are important to understand going into working with data in a scatter plot. So this first vocabulary term is the independent variables. So this is our x-axis. It's going to be what's represented on this horizontal x-axis. A lot of times, it's actually just time. So I'm going to say an example is time. So hours, years, things of that nature. And this is the variable that is going to change on its own and not be influenced by anything else. So this is just independent. It is not dependent on anything else. So on another factor. So this is why time is the perfect independent variable, because time is going to pass. It's just going to occur, and things might happen during the time, but time is not waiting on something else to change. It changes on its own. Then we have the variable that is influenced, that does change depending on our independent variable. So this we put on our y-axis. My favorite example for our dependent variable is money. So a lot of times the more hours you work or the more time that passes, the more money is earned, because a lot of times, you have a salary that is, pay per amount of time. So it's really good to use money as an example of what we would represent as a dependent variable, because a lot of times money depends on the amount of time that has passed. So I'm going to say this is dependent I'm trying to think of our simplest way to explain this. It's dependent on the other factor. So the other variable, the other item that is involved, a lot of the times it's our time, that's what it depends on. And it changes accordingly in relation to that other variable. Then I have the definition of a scatter plot, which is just a graph that relates two different sets of data by displaying them as ordered pairs. So we're plotting points on a coordinate plane. That is all a scatter plot is. So if we're looking at a scatter plot, we have some different ways, some different patterns that we can see. When there is absolutely no pattern that seems to be apparent, so in this case, these dots are just all over the place, we say that has no correlation. Or you could say no association or no relationship. This just means that there is not a pattern between X and Y that we can use to predict Y given X. There's just no apparent relationship. When we do have an apparent relationship, for example, we can tell that this graph is going upwards and this one's going downward, then we describe it based on what this slope would be if we had a slope for a line going through it. So if it goes upwards from left to right, we say that this is a positive correlation or association. And then if it goes downward, like a negative slope, it's a negative correlation. So those are our patterns that we can look for. So it's really important to look at your data and understand that if my X increases and my Y is increasing with it, that's a positive correlation because the two increase together. Where over here, as X gets bigger, Y actually gets smaller. So they're not changing the same direction. As one gets bigger, the other gets smaller. So we call that a negative correlation. So knowing that information, we can start to actually use information and try and create data on the relationship and make an equation, understand slope, and things of that nature. So first, I'm going to just graph our points. So for this first letter, we have 3 coordinates that they've given me. We've got 0, 10, because that's what the table says. So we're going to go 0, 10, and I'm going to put a point. My next point is at 2, 7. So I'm going to go over to 2 on our x-axis, and I'm going to go up to 7 and put a point. And then we've got 4, 2. So I'm going to go over to 4, up 2. And when I just look at this data, I can tell, looking from left to right, that we're going downward. So I can identify the relationship as being negative. So that's what we're going to do before we start to worry about these other aspects. So we said that that was a negative relationship. Let's do the next one. I've got a coordinate at 1, 0. So I'm going to go 1 and then up 0. At 6, 9. And then at 8, 4. So this one really does not have a strong relationship at all. It would be beneficial for us to have more data points than these 3 in order to determine there is any amount of relationship. But because there is some sort of pattern, you can kind of tell that it is positive. We're going to go with positive, but we're going to think about the fact that although we see this positive trend, it's not a super strong relationship because it's kind of going doop, doop, instead of just a straight line. So we can think about this as being weak. And then the last one, we're going to plot our point. I actually had to make my scale counting by 2s on the Y because our maximum Y value is 12, and I wouldn't have been able to fit that data point if I had counted by 1s. So I actually counted by 2s on my Y. So just keep that in mind as we plot these 3 points. My first point is at 2, 1, which is going to be about halfway up. My next point is at 3, 5. So again, in between the 4 and the 5. And then my last point is at 7, 12. And this one's a little bit better of a positive correlation than that last one.